Hello there. Russell Goodman, Supply Chain Brain Senior Editor here, welcoming you to our presentation today, in which we're going to talk about robotics, optimizing your company operations. The title for today's program, Let's Talk Robots, 4 real-world use cases transforming the supply chain. I don't have to tell you that high cost and inefficiency are built in when you move products and materials around manually. Well, let's face it, traditional material handling equipment has its limitations. Wouldn't you prefer to make your operations more productive and make your employees' lives easier? Well, you can by leaving materials movement to flexible, cloud-driven, autonomous mobile robots. And that's precisely what we're going to talk about in today's discussion about AMRs. Now, here are some of the valuable points that you're going to take away from today's program. How to optimize workflows in manufacturing, such as lineside delivery and warehousing. How to increase throughput while regaining valued floor space. You'll hear about the power of ecosystem collaboration. And without a doubt, you will hear how to make your existing workforce more productive, performing more value-added tasks. On board today to walk you through all of this is Eric Hardy, Senior Director of Strategic Initiatives, Zebra Robotics Automation, Zebra Technologies. Now, in that capacity, Eric is responsible for leading robotic automation's efforts on overall strategy, partnerships, M&A, and ventures. He has more than 20 years of international experience in technology, both in developed and emerging markets. Eric holds a bachelor's degree in environmental engineering from Tulane and an MBA from the Ross School of Business at the University of Michigan. Additionally, Eric served on the Association for Advancing Automation's Robotics Technology Strategy Board from 2021 to 2022. So believe me, you want to stick around and hear what robotics can do for your operation and what Eric can tell you about that. All right, just a bit of housekeeping before we get underway. A Q&A session will follow the presentation, and the way that you participate is by filling in the box at the bottom of your screen with your question. Eric will address as many as possible before we sign off. But not to worry, any questions still pending, he will get to offline. All right, and now to our presentation and to Eric Hardy of Zebra Robotics Automation. Eric, welcome.
Thank you, Russell. I look forward to presenting here and walking through these use cases. So let me just get started and give you guys some background here. So what we see in the supply chain, it's complex and getting more complex every day. We have customer demand that's increasing as well. And in order to meet that, the challenges that we see customers facing or supply chain providers facing are labor shortages, uncertainty, and disruptions. And when we're talking about labor shortage or labor challenges, it's labor shortages, high turnover, the time it takes to train someone and bring them up to the task, and then increasing labor cost and safety concerns as well. And when you look at the environment, there's uncertainty with higher volumes of orders and the fluctuation that we had from the pandemic and then the coming off of the pandemic afterwards, unpredictability in inventory availability, and then unpredictability in the product mix that you need to supply, as well as changing customer service expectations. Disruptions that we see in the supply chain, the rapid growth of e-commerce, shorter delivery times being required, and the rise in item level fulfillment, as well as technology innovations and new operational risk and requirements. Now, according to Gartner, AMRs provide a readily and inexpensive way to implement and are more scalable and can help you manage through these extremes of peaks and troughs of demand that you're seeing out there. And a higher percentage of companies are now pursuing warehouse automation due to the challenges in the supply chain and the labor shortages and the associated cost reduction that you can get implementing AMRs and overall automation. So let me look at some of these challenges here about attracting and retaining warehouse labor. What we saw at the end of 2022 was roughly 477,000 openings in transportation and warehousing. And then we also saw 35% of warehouses using seasonal surge labor to help handle the peak that's coming. And peak here is around the corner, starting in October. So the O&D period, October, November, December. We'll see more demand for labor during those periods as well. And the average hourly wage of around $21. That's we've seen that increase over time as well. And then what we also hear from, or actually we see in the data here, that 29% of warehouses, it takes them less than a month to bring people up to speed on tasks and whatnot. And Amazon had an overall annual turnover there in their warehousing operations of about 150%. So that's a lot of people that need to be trained up and brought into these tasks and whatnot, and understand the workflow and how you're doing your task in the system. And I'll explain a little bit more about that later as we get into this, about how AMRs can help with these challenges. On the manufacturing front, they've also had challenges as well. So they're predicting, looking at a report from Deloitte, that 2.1 million manufacturing jobs will go unfulfilled due to a skills gap between 2020 and 2030 there. So there's a lot of opportunity to introduce automation to help fill these skills gap and still meet your SLAs or your customer demands that you have out there. What I want to do today is walk through 4 unique AMR applications for warehousing and manufacturing operations. And I'll go through each one of these. And what I'm showing here are also some of the outcomes that we've been able to achieve for customers by implementing these use cases. So lineside delivery, here we're able to increase this customer's capacity by 3x, so tripling their capacity. Pick to tote, we were able to improve their cycle time by 40%. And then transporting to and from ASRS, that's another use case. Here we were able to increase our customers' throughput by 25%. And then finally, what I'll do is cover fulfillment operations, which is fulfilling e-commerce orders. We were able to increase their productivity from 35 to 45% in their operations. So let me jump into it here. The first use case that I want to go over is lineside delivery. And typically, when you're looking at lineside delivery, the traditional ways that materials have been delivered to a manufacturing process have been through manual cart transport or an AGV. Manual cart transport, that is someone pushing a cart in between the work cells and moving product in between operations there. So workers have spent over 50% of their time doing this unproductive walking and can walk up to 50 miles per day in large facilities. And then also what we've seen is with the labor shortages, often the skilled technicians are tasked to move the material. So that's someone that's operating a work cell. Once they've finished creating a certain number amount, or that task, that ticket there, they'll move it to the other work cell. What you can do is automate that with an AMR where it's automatically moved and the workers can stay focused on their task of the value-added task of the manufacturing cell. Also, what we've seen historically in the past, AGVs, they have moved product between work cells. The difference between an AGV and an AMR, I'm going to talk to you about AMRs, or autonomous mobile robots. AGVs, they travel on fixed path and they require infrastructure to help them navigate that fixed path and know where they are in that facility. And that infrastructure is tape, wire, or beacons. And they don't have as complex obstacle avoidance or collision avoidance that we have in the AMRs. And then generally they're focused on a single task or a fixed task operation. And I'll show you some use cases that we have here as we walk through it, where the AMRs that we're offering can be tasked to do different operations. and that's through our fetch core, our software that controls the AMRs as well. So let me jump in here. This is a line side delivery, the use case that we did for a customer. The solution here, Zebra AMRs, which you see there on the right-hand side of the screen, that is our roller top. It's loaded with raw material, and then it moves between the workstations. You can see a workstation behind the AMR. It is going to drop off that tote, and then it will drop off that tote and pick up another tote and be routed to the next production station. The benefits that the customer received from this were freeing up the space and increasing flexibility in their operations, and then keeping the technicians, the operators, more focused on their tasks rather than moving the material between different workstations. Here we were able to increase their productivity or their production capacity by 3x, and overall improve their floor space utilization by 33%. And what I want to do here is first walk you through, this is the operation before. You'll see they had a conveyor in there that was connecting the work cells to the different operations. And what would happen in the conveyor here, give me a second. What would happen in this workspace, the conveyors, if it missed a divert, the tote would go around again. And what this customer told us is sometimes they would find totes that were recirculating for 3 to 4 days. In addition to that, so when those totes are circulating, that's an order that isn't being produced, or a product that isn't being produced that delays times as well. And then what you have with conveyor, it's linear, and if you miss a divert or you miss some of that, it's going to go around again. Or let's say it misses a divert, you could lose, or something happens where that conveyor goes down, you can miss a whole line of that operation or that part of your operation. AMRs have that flexibility where they can drive around each other or avoid obstacles, drive around the obstacles and deliver the product on time. So let me show you here. This is after the operation, after we did the automation, did the implementation. Here, the AMR is going to pick up the tote. It will drop it off at the destined work cell. We actually scan it in there using Zebra's FIS or fixed industrial scanning technology. It scans and it lets it know that this product was dropped off. And then the AMR will go to its next task of picking up either a finished good or a work in progress and moving that from one work cell to the other, or picking up raw materials and starting the process over again. We've gotten many compliments on this workflow as well. It created more flexibility. And you see, compared to the earlier operation where I was showing you the before, the floor space is more free. They can add in more workstations, and the AMRs are able to navigate in that area as well. So let me move on to the next. Next use case I wanted to talk to you about was pick the tote. Here, traditionally, so for this customer, what they were using was manual operations and conveyor to move totes to their pack out areas. Here, when you take a look at and compare AMRs to fixed infrastructure is generally deployed once, and it's rarely modified, or it takes some more effort to modify that and change that. It performs a single workflow and then occupies more valuable workspace, and it's unidirectional. So as I mentioned, as the conveyor goes forward, if there's a problem, you lose that conveyor section and that goes down. You can't go around, it can't be redirected. AMRs give you that flexibility where you can redirect. On the AMR side, it's flexible system-driven automation. You can deploy it quickly, and you can iterate and change that workflow as needed using our fetch core software. You also have flexibility to change and scale those workflows as your business needs change. So during peak, if you need to add in more robots, or if you're looking at, hey, we want to route more to this area over here, we're able to adjust the workflow and get those robots moving in that direction fairly quickly. It also doesn't require additional floor space or added infrastructure, and it's the multi-directional flow, so it eliminates what we call the linear bottlenecks that you see in conveyor. And then here's just a comparison here. If you're looking down an aisle, you can see if you put a fixed conveyor in there, it might take up so half to a third of that floor space there. And the AMR is only going to occupy the floor space that it's going down at that time, right? Now, so is there a place for conveyors? Yes, they work very well for high output and high throughput. AMRs work well for moderate throughput. And if we look at it cost-wise, AMRs are generally lower cost compared to AMRs. And again, I think it's the flexibility that the AMR provides and that ability to move in multiple directions. So for example, if we're looking at this, the example of the photos we have there on the left, if that conveyor goes down, that whole operation of that area is not accessible, or you're not getting product out. If there's an obstruction here, if you look at the bottom row there, or aisle there, if there's an obstruction, the AMR will try to get around it. And if it doesn't, it'll go back and go out another way. So you can still use part of that aisle space and still productive for you in that operation. Now, let me walk you through pick to tote or push button delivery here that we did for a Fortune 500 distributor. Here, what you'll see is the associates are walking down the aisles and picking and then dropping it into this bin that you see there in black. And then they push that IoT button that is in green there, and the robot will come and pick it up. And what I'll do is I'll show some before and after here so we can take a good look at what this operation is, how that's performing. And so once the IoT button is pushed, the roller top comes and it picks up that tote, and then it'll take it and drop it off at the conveyor spur. Now, what we've been able to do is increase their daily throughput compared to manual operation. We've eliminated the walking and transport, and we've also been able to regain floor space. Here we regained over 13% of their floor space. And what they're able to do is when they regain that floor space, they put in more storage. So that enabled them to get more usage out of their warehouse, their existing warehouse. So the results here, 35,000 labor hours saved per year, and they increased their cycle time 35 to 40%. And as I mentioned before, 13% floor space. So let me show you what this operation looked like prior. Here you can see the associates are picking down the aisles, and they're taking the totes, putting them on the cart and pushing them to part of the conveyor spur. And then from that conveyor spur, they're offloading that tote onto another tote, which then transports it through their facility. Now, what they were able to do with the operation that I just showed you, and I'll show you a video of this, they're actually able to pull out some of that conveyor and have less conveyor in there because the mobile robots were driving further and dropping them off at that location. So as I mentioned, they pulled out the conveyor and they were able to put in more storage there. So, and that enabled them to better utilize their facility. So here, once again, just walking through this and giving you a visual of what this looks like. The person picked in that aisle, you can still see the associate there picking. They dropped it off at the end of the aisle here and hit the IoT button. The mobile robot or the roller top AMR came over and picked up the package there, or the tote. And now what it's going to do is transport it through the facility. And you'll see it is collaborative. People can walk by. It'll avoid people and obstacles as well with our 3D vision system. And what it's going to do is it's going to drop it off at one of those conveyor spurs. So here, in keeping with our themes, what they were able to do, the customer here freed up their workers to do more value-added tasks, such as staying in that aisle and continuing the picking. And then we also freed up the floor space by taking out the conveyor, which again, as I mentioned before, if that goes down, you lose part of that section of the conveyor. Now we're still transporting to that conveyor, but the mobile robots can drive around and do obstacle avoidance and offer that flexibility in the automation there. So let me roll on to our third use case here, which is transport to and from ASRS. Traditionally, when you're looking at ASRS, here what I'm showing is a vertical lift module. To get things in and out of an AMRS, or sorry, to get things in and out of ASRS, traditionally you use manual cart transport. And again, you see workers spending 50% of their time transporting material and can walk over 15 miles per day in these large facilities. Or another way of getting it out, a worker will pick and drop it off into a tote, which is on a conveyor system. And again, these conveyor systems, it's fixed infrastructure. It can be more expensive than an AMR to maintain, and it can create some congestion and access issues around the ASRS. It also will limit the expansion that you can do with an ASRS. So if you wanted to expand outward in this case, or add in more, you'd have to pull up that conveyor, and there's costs associated with that. With an AMR, when you implement it, you just reconfigure the map using our FetchCore software and change the drop-off points, and you're good to go once you do that. So you don't need to rework all of the infrastructure there that you would with a fixed conveyor. So let me walk through this use case here at a customer that we did. Here's another distributor of electronic components. And I'll show you the before and after here. What they're doing here is picking into this from this horizontal carousel there, putting it into the bin. That bin is then transported to the pack out area, and associates don't have to leave the storage area. And so what we've done is freed up the floor space as well. They were able to put in another carousel. And then in addition to that, what you'll see, what we've been able to do is interleave some different workflows here, or work streams. In addition to doing the ASRS to pack out, we also do dunnage transport. So after they picked goods, or when they're actually picking the goods to put into the ASRS, so they're breaking down that, picking from a box, the dunnage or the box is discarded, and then we'll run a workflow where we pick up that discarded dunnage and transport it to the disposal area or recycling. And here with this customer, we were able to get a 25% throughput increase, and we're getting 13% of their floor space. So let me show you, here's a view of what it looked like before. You can see the conveyor up top there that is transporting goods to and from the carousel areas and the picking areas as well, over to pack out. What they are able to do is remove that floor space and put in another carousel, or sorry, remove that conveyor, which freed up the floor space, allowing them to put in another carousel. In addition to that, and probably more importantly, the conveyor was capped out at roughly 800 orders per day. And what we were able to do is by pulling that conveyor out and inserting the AMR solution, we were able to increase their capacity there up to 1,000 orders per day, which allowed them to get more from their space and their current facility. So let me show you the operation here. Here's the AMR. The associate there has picked into those totes from the horizontal carousel. This AMR is going to transport from that carousel over to the pack out area for shipping. And you'll see they've freed up that floor space. You don't see as much conveyor in there prior. And here it's going to the pack out area. Now, what this also allowed them to do was better utilize their people as well. So their overtime went down because they were able to hit their throughput or they were able to increase their throughput. And some of the comments that we got from the workers were, hey, this is great. My overtime is down. I'm able to leave on time, and I'm getting more out of my day and being more productive. So oftentimes it's about making your people more productive in what they're doing, not necessarily reducing the amount of workers you have, but allowing them to be more productive and not doing overtime, which then saves you cost and whatnot on that side of the equation as well. So here, let me move on to our next use case. So fulfillment. Fulfillment, so this is e-commerce order picking. Generally how that's done today, you have associates that are walking the aisles doing the picking as we have pictured here. They can spend over 80% of their time doing unproductive walking. And in this case, in fulfillment operations, they can oftentimes walk over 20 miles per day. And they're also experiencing, pressures to work harder and faster. And some have had some challenges of experiencing some pain when doing the work duties as well. Now, what we've done with our fulfillment robot, so the flex shelf that you see there on the right, you can see that when you take a look at the manual operation, there's a high percentage of time that's spent walking. And because they're doing more walking, they're doing less picking in those operations. And with the mobile robot, what we're able to do is the cart comes to them and they're able to pick into that cart. So they spend less time walking and more time picking. So here's an example where the associates, 10% of their time is doing walking and 90% of their time is picking. And here the use case, we worked with a leading third-party logistics provider, and we implemented our flex shelf here. Basically, we load the empty totes, they're scanned in and loaded onto the robot, and the robot moves into the pick location or the racking, where associates are, or pickers are there, and they meet the robots in the aisles and pick directly into the robot. You'll see there's a touch screen there that tells them what product to pick, and we also have an onboard scanner here that scans the product, so you can scan the product and confirm that the right product was picked, and then directs the worker to put it into the right tote on the robot. And then once they're picked, their orders are completed. The robots automatically deliver those items to the pack out area. So the picker stays in the pick area, and the robot exits the pick area and drops it off to the pack out area. Now, in the past, or in the manual operation, generally the workers are moving that to the pack out facility as well. So the benefits here with this operation, the staff stays focused on the picking rather than doing the unproductive walking. You free up staff to do other operations such as return and replenishment. And then one benefit that we have with the AMRs here, we work on the existing wireless infrastructure and don't require new infrastructure to be installed. So the result here is a pick productivity increase of 35 to 45%. Now, what we see is, how do we get at these use cases? So what we do is we look across the value streams of our manufacturing operations of our customers and our warehouse operations. And by looking across these, we're able to identify pain points that our customers are having. And we work with them to see how we can free up their employees to do more value-added tasks with AMRs, and also free up the workspace. So here down below, what I'm showing is some examples of, again, more examples of the use cases that we talked about, and other examples as well. So, and these are the customer results that we were able to achieve. All right. Well, thank you. And
Eric, that was a terrific drill down into 4 very, very important functions in the warehouse and in the distribution center space. No doubt about it. Valuable information. Well, the questions are pouring in, so I think we need to, without further ado, get to them. A little review with this particular question. Let's talk about, how do AMRs differ from conventional fixed automation solutions? Well, what would you say?
Yeah, so the AMRs differ from traditional or conventional automation or fixed infrastructure. The main areas are the mobility that you're providing, the flexibility, and also the scalability. And what I mean by scalability is the ability to add more robots and scale your operations as you grow. Flexibility, I touched on this in the presentation. You're not constrained by linear bottlenecks of when a fixed infrastructure goes down, you lose that conveyor, or if you miss a divert, it would go around again. The mobile robots are flexible and can navigate around obstacles and move to where you want them to go in a certain amount of time. And we're able to control that through or not control necessarily, but we're able to manage that through our fetch core interface.
I just want to remind everybody that if you have not submitted a question already, please do so. And again, if we are unable to get to all of the questions during the presentation today, Eric will answer them offline. All right. Someone says, I'm interested in getting started on the journey of robotic automation, but where do I start? Well, what would you tell them?
Yeah, so the first thing I would say is take a look at your processes. So, and understand your workflow. So how are you moving product through your facility? Oftentimes, what we find is that the process itself isn't efficient. And so understanding what your process is, and then taking a look at how often are you doing this? How often are you moving materials? That's very key. And then how far are you moving them as well? So some of the things that we found is that, so in general, the higher shift, the higher shift operations you have. So 1 shift, 2 shift, 3 shifts, the more shifts you're running, the better your ROI is going to be. And the longer the distance you're moving, the better your ROI is going to be. That's not to say it doesn't work in 1 shift shorter scenarios. It's just in general, in longer scenarios, it does work better.
Valuable question here, it seems to me. Someone wants to know if there are any common challenges or obstacles that organizations face when they are implementing AMRs. And of course, if that happens, how can they be addressed? Valuable question. What do you tell them?
Yeah, so I think that so some of the common challenges that we faced, you have to take a look at the way that you're operating, the environment that you're operating in, and how often you're going to be able to use these robots. And what we do is we work with our customers and do a risk assessment and a walkthrough, and we lay out how this operation looks. And generally what we found is people are very open to these to AMRs, and what you really have to focus on is the benefit that you're going to get from them. And this comes from taking a look at your ROI and how you're operating and how you can improve your operations. So, I think that you're always going to find challenges, and it's how you approach that. And what we found is approaching with a very data-centric approach helps you kind of overcome those obstacles by saying, look, this is how we operate, and this is how we can improve the operation and where the mobile robots will add value.
Eric, they are really pouring in, but here's one that's interesting for fulfillment. If the picker still needs to walk to all of the pick faces, how does the robot reduce walking? Important question. What do you say?
So the way you take a look at that, you're reducing the overall walking in the facility. So keep in mind, they're also walking to and from dropping the orders off of where they need to go. And in addition to that, what we do is we look at optimizing that picker movement in the actual field itself. So they're actually, when you're recommending they go to a different location, that we're looking at how do you optimize that person so that the walking is less. Not all picking algorithms take a look at doing that, right? And the robot will meet them, allowing them to stay in a space and do better picking there.
Here's still another one. Are there bots that can be used in public environments like healthcare settings versus WHS? What do you say?
So we do have, so mobile robots can be used in a bunch of different places. So public settings, you do see robots in healthcare buildings as well. You also see them in restaurants. We have a OEM product line that we work with Dillinger Robotics on, and they are operating in hospital and healthcare spaces as well.
Now, folks that might be using AMRs to move dunnage, do they just set up the AMRs on a schedule, or does someone still have to trigger things per se?
So it all depends on your operation. Some do. So the short answer to your question is yes, they do both. Yeah. What we allow you to do with our fetch core is to set that up. So fetch core is our cloud-based interface, our cloud-based platform for our mobile robots. And what they allow you to do is set up that so that you can trigger it either on demand by pressing a button that's on a tablet or an IoT button, or you can set it up so it's scheduled at like noon, it's going to move. Now, that's all going to depend on your operations. Some operations will know that they have enough dunnage at noon where they can transport it, so it'll be ready to go. Not everyone is like that. And that's where the beauty of FetchCore allows you to customize that and set that up to your needs. Yep.
Now, this questioner noted that all of the use cases that you presented and discussed today were for warehouse movement. So the question then is this: what about delivery from warehouse to work site environments? Good question. What do you say? What would you tell that person?
So I probably need to kind of clarify some things here, what we mean by work site. So the AMRs, most AMRs do not go in and out of facilities, so inside or outside. So inside a facility, the AMR can move and drop that off between workstations or work cells. That was kind of the first use case that I was talking through about line side delivery. Now, we do get questions of, we've looked at manufacturers where they have one building and then another building like across the street, right? So the AMRs that we're offering do not navigate across streets or they're mainly inside and indoor focused. The challenge you have with outdoors is the environment's different, the lighting situation's different, and then the environment, the floor itself could be different, right? So depending on where you live, you're either facing heat, rain, snow, all those different obstacles, which are a challenge for AMRs.
Yeah, sure. Those elements could be quite difficult, no doubt about it. Scalability question. How scalable is the adoption of autonomous mobile robots, and what factors should be considered top of mind when planning for scalability? Well,
Yeah.
walk us through that. What do you say?
So most of the times, the short answer is it's very scalable. What we've seen with customers is, start small, prove the use case, and then look at how do you build that up. For example, you just start, like we could use that pick to tote example. They could just try out for one area, use that push button operation, and then scale it out through the rest of the facility by adding in more push buttons and call stations and adding in more robots. So typically what we suggest is start small, no integration, then you can get a feel for what so if you're challenged with how you can adopt this, that'll give you a good feel for how that operation is going to run. We do have customers that go all out. They have the full integration and everything. But what you do is generally what we've seen is customers prove it in one facility and then look to replicate that in their other facilities. Now, each facility is going to have a little bit of nuance there of their different operations. So we work with the customers to develop that. So that's the scalability. You typically go from an initial rollout to a full rollout where you're going from different facilities. So what I've sort of walked you through is doing a POC, then to a full rollout with the facility, and then moving to multiple facilities.
I must admit, this question that I'm about to pose occurred to me as I was watching the video. It's a maintenance question. What consideration should be made regarding maintenance and upkeep of AMRs to ensure a continuous operation? Very important question. What do you say?
Yeah, so we offer, so there is annual routine maintenance that needs to be done. Oftentimes, one of the issues that we see is some of the cameras are dirty. Just dust accumulates over time. And wiping that off through our process or following our procedures can help you improve your facilities. But in general, there's overall hygiene that people need to be aware of, meaning you have to keep your floor space clean. You can't, the more clutter that's on the floor, the less efficient the robots are. So you have to have a certain hygiene that you're keeping in that environment. And what I mean by that is when one takes a look at conveyors, they generally there's a maintenance schedule with a conveyor, and it's the same. And there's a hygiene with the conveyor. Like you just don't put stuff on conveyors and use them as storage and expect them to work like forever that way. And so what you can do is you want to keep that annual maintenance or that routine preventive maintenance ongoing with your AMRs as well.
I would imagine this question is a sort of a subset of the one you just answered. It has to do with battery life. What is the typical battery life cycle of a battery, and can it be replaced? Should it be replaced? What do you say?
So the AMRs, they dock onto an AC charge dock there that we built and does the charging. Typically you can charge them on demand or automatically. You set that up in FetchCore, and generally they will run for approximately 9 hours, which is generally a shift operation there. And the usage and battery life is going to depend on how much load they're carrying. So the heavier the loads, the more it's going to use the battery more power to transport that load. In general, we recommend replacing the batteries roughly about every 2 years.
Here's the safety question. I know it often comes up in the context of forklifts and that sort of thing, but how do you ensure the safety of both the robots and the human workforce when they're working together in the same environment? So very, very important question there. So walk us through that. What do you say?
In our installations, what we do is first is a risk assessment where you're taking a look at see what risks are out there. And then we work towards adhering to safety standards as well, like R1508. And then our mobile robots are built with built-in safety features. There's a run stop button on them as well. And they have obstacle avoidance using our 3D cameras and LiDAR to help navigate through the facility. So they are safe to operate with. You do have to focus on worker training and the operations. Some people like to play games with AMRs. We don't recommend that because it's AMRs will avoid obstacles, and that's what they're built to do. But generally, people are smarter than AMRs in some areas. Yeah.
So no racing of the AMRs in the warehouse. This is a return to the startup.
Yeah, we definitely don't recommend that. Yeah. So.
So if we were embarking on our journey to begin this robotic automation, let's talk about concerns like costs. Let's talk about infrastructure and that sort of thing. What areas should be top of mind then when we're thinking about doing this?
So we don't need an additional infrastructure. We're able to work on the existing Wi-Fi that you have in your operation there. Now, what we do is an assessment of that Wi-Fi, and there are certain areas where you might not be getting good Wi-Fi coverage, so we recommend boosting the Wi-Fi or augmenting the Wi-Fi there. I think that on the infrastructure side, that generally is what we take a look at. And we're fairly light because we're cloud-based, so there's no on-prem software. And you can use a tablet or any web-based, a web browser to access the FetchCore as well. So.
All right, let's talk about actually getting underway. Let's talk about initiating the deployment of these robots and building workflows. So walk us through that. How do we get that underway?
Yeah, so the first step is, so generally what happens in the process of designing the solution, we have a good idea of what that workflow looks like. So what I'm going to address is the on-site, what happens when you get that up and running. So generally the robot is uncrated, and then we take one robot and we use a joystick to drive it around and map the facility. So when it's mapping the facility, it's laying out the facility so it knows where the walls are, where obstacles are, and the aisles. And then what you do is you're able to annotate, like this is the drop-off area, this is the pickup area in FetchCore. And then what you do is you use our visual designer there to drag and drop and build that workflow of moving the material throughout the facility. And then generally these are up and running in less than 72 hours. Some can be up quicker. It all depends on the level of automation and integration that you require.
Great, that's quick, and that leads me into a very important question, and that is those persons who are going to be operating the equipment, operating the robots. What kind of training or skill development is necessary for them?
Yeah, so we offer training with our program. It's actually very simple and easy to use. What we have is the cloud interface is very intuitive. You're able to drag and drop and build your software, build your workflow profile in our software. And then the workers that are putting things into and off of the robot, there's training that we work with our partners and customers to provide so they know how to get up and running quickly.
So let's talk now about the use of third-party software then. Integration. What level of integration is going to be required, when you're dealing with third-party software? What do you say?
So that all depends on what you're trying to accomplish. We've worked with companies that integrate into their WMS. We've also worked with companies that integrate into your MES or manufacturing execution system. We've also done standalone deployments where, as I was showing you, it's just a push button. Once it's done, it takes it and drops it off and is inducted. We've also done installations where it's as basic as you access fetch core through a browser that's on a tablet, and when you're done or when you need a task, you push the button there and the robot performs the task that you've programmed into the workflow.
I know one of the things that I would be a question I would want answered if I was to think about investing in this type of technology. What key factors should we be considering when evaluating return on investment? So walk me through that very important area right there. What would you tell me? How would you answer that question?
Yeah, so each of our customers generally have a different way of calculating ROI, but the basics are relatively the same. And what I mean is they take a look at their productivity gains and their throughput gains, as well as how they gained on floor space and what are they achieving in that. And then you also take a look at overtime reduction and whatnot and how employees are being used. And so what we do is we work with our customers on the ROI calculations to see what's the best fit for them in the way that they're deploying it, because how you deploy can also change your ROI calculations. And then what you want to take a look at too, we offer two different ways of procuring mobile robots. So that's the RaaS, the robot as a service, and then CapEx with a SaaS subscription onto the fetch core. So CapEx is traditionally how material handling equipment has been sold in the past, whereas RaaS, that's an all-inclusive maintenance package where we make sure the robots are up and running, and you pay that on a monthly or a subscription fee. Now, generally, when talking to customers, RaaS will hit your OpEx budget, and CapEx obviously hits your CapEx budget.
So if I'm the decision maker, I'm concerned about regaining my valuable floor space. I want to know about increased productivity, et cetera, et cetera. So is there kind of a laundry list of things that you're going to hit on when you're telling me this is what you're going to get? When you're considering return on investment, this is what's going to happen. Walk me through that. What specifically do you tell me?
Yeah, so we take a look at what sort of productivity gains you're going to get. So generally it's a snapshot of before and after. And it's not going to be as nice as I just showed you there, generally of pictures of before and after, because you don't have the after yet. But generally what we do, you don't have the after in real life. We'll have a view of what that looks like and what the schematic might look like there. But generally what you see is here's the gain that you've got from throughput and the gain that you get from your operations and freeing up that floor space. So we can take a look at how much floor space that you've achieved as well. Yeah. Now, what you see is that's going to vary by customer. So we customize that to what customers need in their internal discussions because of the consensus buying nature that we see with our customers.
Eric, I got to tell you, this has been some incredibly valuable information and a lot of it that you have provided the attendees today. But we're running out of time and really only have one more question that we simply have to get to. And this is what it would be. If, for the benefit of the viewers today, what is the nugget, the one thing, the absolutely most important takeaway that you want to leave them with? What would you tell them?
Yeah, so thank you for the opportunity here, Russell. What I'd like to share is what we walked through were 4 use cases that we were been able to implement at customers that allow them to free up their workforce and their workspace, enabling them to power their productivity. And some of those use cases, they range from line side delivery and manufacturing to fulfillment in your warehouse operations. And what I implore people to do is take a look at their operations to see what are the 1 to 2 pain points that they're having on a recurring basis along those lines of worker productivity and floor space.
Eric, again, that is some valuable information. Listen, I want to thank Eric Hardy of Zebra Robotics Automation for sharing his time and expertise with us today. And again, if we did not get to all of your questions, during the presentation, Eric will answer them offline. Now take a close look at your screen right now. This is what I call the call to action. This is very, very important information, and it will be sent directly to you. You don't have to take notes right now. Look at these very important URLs here. This is the kind of actionable information that you receive. This is an add-on, if you will, when you attend a Zebra webinar like this. All of this will be in your inbox very shortly. A big thanks to each and every one of you for attending today. Well, this concludes our presentation. Until next time, this is Russell Goodman, Supply Chain Brain, saying so long.